This is 4-8, slopes of parallel and perpendicular lines. Parallel lines used to be described as lines that go on and on forever and never intersect. But now the algebra definition is really that they have the same slopes. Perpendicular lines are lines that intersect to form a right angle at 90 degrees. They have their slopes have a product of -1, which means that they actually multiply to -1. We call this opposite reciprocal or negative reciprocals. So for parallel lines, you could have like m is 3 and m is 3, the same slope. For opposite reciprocals, if you have m is 3, think of 3 as a fraction, which is 3 over 1. Then the perpendicular, that's a symbol for perpendicular, slope would be opposite, so opposite sign, negative, and then 3 over 1 flips to 1 over 3. That's the reciprocal. So another example, if the slope is 1/2, the perpendicular m would be opposite, negative, and then reciprocal, flip the fraction, 2 over 1. Okay, if the m is -4, well remember, -4 is a whole number, so we put it over 1. Well then the perpendicular slope would be opposite sign, which is positive, and flip the fraction, 1 over 4. In example 1, we need to identify which lines are parallel. To do this, we need the slopes. All of our equations need to have the y isolated to see this, which they are in this case. So this one, the slope is m is 4/3. On a y equals 2 equation, that would look like this. The x must have been multiplied by 0 because it's gone. So I know that the slope is 0. Oops, not y equals. M equals 4/3 and m equals 0. Another line like this at -3. Okay, so then my slopes that are the lines that are parallel, well, y equals 4/3 x plus 3 and y equals 4/3 x minus 5 are parallel. And then y equals 2 and y equals -3 are parallel. Example B. The slope in this equation is 3, y equals mx, so remember the m is 3. M equals -1/2. In the second equation, this is not isolated. I need to move x to the other side, so it's going to become the opposite sign, which is -x. So I have -x and then -4 or -4. Divide everything by 2. When we divide, we do it to everything when we're isolating. And so we end up with negative, remember in front of the x is really a 1, so that's -1/2 x minus 2. And so therefore my slope on this one is -1/2. And my last equation's in point slope form, so to get that to slope intercept first we distribute. That would become 3x minus 3. Then we add 5 to both sides, but you can only add and subtract like terms, so I'm not doing it to everything. So then I get y equals 3x plus 2, so my m is 3. So my equations that are parallel would be y equals 3x plus 2 and y minus 5 equals 3 parentheses x minus 1. My other lines that are parallel would be y equals -1/2 x plus 4 and x plus 2y equals -4. To identify which lines are perpendicular, I also need to make sure that y is isolated. Okay, in the first one there isn't even a y. That's an undefined slope. This equation, the whole line would look like this. And so I know that when I have an x equals and my equation looks like this, my slope is undefined. And a y equals equation would look like this. So I know that my slope is going to be 0. And these are actually, let's see, if you notice, if I drag that line over, it's going to be perpendicular or form a right angle with an undefined slope. So these are actually perpendicular. Okay, and then my last two, let's just double check. So this first equation has a slope of -4, And this one is not set up correctly, so I have to go through and do a little bit of work. 1/4 x plus 1/4. And I'm going to subtract 2 from both sides. The last step really doesn't affect the slope at all. So my slope in this one is 1/4. And notice these are negative reciprocals, because if one slope's -4, which is -4/1, the other one would have to be the opposite sign, which is positive, and then flip the fraction upside down. And that's true. So these are perpendicular to each other as well. So my two equations that are perpendicular are these two at first, and then these two. Write an equation in slope-intercept form for the line that passes through this point. So I'm given a point so far, and is parallel to this graph. Well, if it's parallel to that, then I know that the slope is going to be whatever's in front of x, which is actually a 1. So my slope is 1. And now think about this. I have a point and a slope. My slope is 1, and my point that I'm using is -4, 1. And so I'm going to write an equation. Sorry, a parallel line also has a slope of 1. But I'm going to write my equation in point-slope form now. So start with my equation, which has been written for me. And then I'm going to label up above my x1, y1, or here as well, it doesn't matter. Y minus y1 is 1, equals m, which is 1, parenthesis, x minus -4. Minus a negative becomes a plus. Then to get this to slope-intercept form, I had 2 steps. Step 1 was to distribute, and step 2 is to isolate y. So let's do that. So if I distribute my 1, it doesn't really change anything because it's the identity property. 1 times x is x, and 1 times 4 is 4. And then isolate y by adding 1 to both sides, and I get y equals x plus 5. This is the same idea, but now with perpendicular. We're provided a point. Write an equation in slope-intercept form for the line that passes through the point, 6, 4, and is perpendicular to the graph, y equals 7x plus 1. So if my slope is 7 here, I need a perpendicular. Since it's perpendicular to, I need a perpendicular slope. So perpendicular slope would be opposite sign, which is going to be negative. And the 7 is going to flip. Remember, 7 is 7/1 right now, so I'm going to flip that fraction to be 1/7. So my slope right now is 7, and my perpendicular slope is -1/7. And now I have to write my equation. So let me label my x1, y1. So using the point-slope form, since I have a point and a slope, I'm going to do y minus 4 equals -1/7 x minus 6. Remember, to get to slope-intercept form, step 1 is to distribute. So I get y minus 4 equals -1/7 x plus, because negative times a negative is positive, 1/7 times 6 is 6/7. Now I'm going to add 4 to both sides. You can do this in your calculator, or you need to get a common denominator. To get 4, the whole number 4 with a common denominator of 7, I'm trying to think what divided by 7 gets me 4, and that's 28. So instead of writing the number 4, I can just put 28/7 in that spot and add 28/7 to 6/7. So we add the numerators, 28 and 6, and we get 34. And we keep the denominator 7. And I'm just going to make sure that that's simplified, but it is. So my final answer is y equals -1/7 x plus 34/7.